Welcome everyone to part 2 of Systems of Equations. We're doing the substitution method. This is probably the method most familiar to your average student, and rightfully so. You have more exposure to the substitution method than you do some of the other methods. So we're going to kind of break this down to steps. In case you haven't seen it, let's go ahead and get started. Here we have 2x plus 3y equals 12, 2x plus y equals 8. We're asked to find the solution of this to this system being two or more equations. The first step is isolating either x or y. So we want to isolate x or y. And it doesn't have to be x or y. It can be like m, n, whatever the variables are. We want to isolate one of them in one of the equations. The preferred coefficients, we want either 1 or -1. What does that mean? We want like a 1x, which is the same thing as x. Those are preferred, or like a -y, which is the same thing, -1y, which is the same thing as -y. Those ones we prefer because it's a little bit easier to solve for them. So let's go ahead and apply step 1 in this situation. So we're looking here at our different variables. We see we have a 2 here. That's no good. That's not preferred. 3 is not preferred. Those are our two coefficients in the blue equation. We have 2, again, not preferred. And then we look here at the last one, and we see y is by itself. And it's technically a coefficient of +1. So we're going to try to isolate that y. That's going to be our goal. Okay, so we're going to apply step 1 now. So we're going to apply step, oops, that's not how you write, step 1. Now what we're going to do is I'm going to rewrite the equation 2x plus y equals 8. And I'm just going to solve for y. I'm going to move everything over. -2x, -2x. And I get y equals -2x plus 8. Okay, now I am done with that step. I'm done with step 1. So I'm going to put a box around this. I don't like that color. I want it purple. A little more color. So I'm going to put a box around this. I know the value of y. I have y by itself, and y is equal to -2x plus 8. So what do I do now? What I'm going to do is I'm going to take this value and I'm going to plug it into y in the other equation. Okay, and I see I have some purples kind of mixed and matched. Don't like it, so I'm going to change this to pink or magenta, whatever you want to call this color. That's what I'm choosing. Okay, so I'm going to change it, and I'm going to plug it into y into the other equation. So step 2 is plug the value of the variable into the other equation and solve for the other variable. Okay, a lot of talks of variables are kind of tough to make sense of it, so we're going to go ahead and apply it here. What we're going to do is we're going to rewrite the blue equation, but with one addition. The addition is we're going to remove the variable. Now, why do we do this? Why do we rewrite this equation with the variable in question? Well, it's because we need only one variable to be used in the entire equation. If we have two variables, there's nothing we can do. But if we have one variable, then we can solve for that one variable. So what I'm going to do here is I'm going to be plugging in this 2x plus 8 in for y. So instead of writing 2x plus 3y, I'm going to write 2x plus 3 times -2x plus 8. Remember, this is 3 times y. So whatever y is, we replace it and we multiply it. Okay, so let me actually go up so I can solve. All right, so now it's just a matter of solving. So I'm going to solve here in dark blue. So I have 2x plus, I need to distribute here. That's going to be minus, actually. So I have 3 times -2 is going to be -6x plus 24 equals 12. I have like terms here and here, so I'm going to get -4x plus 24 equals 12. I'm going to subtract 24 from both sides. 24. I get -4x equals, what is that, -12. So I divide by -4, divide by -4, and I get x equals +3. Okay, we're ready for step 3. It says plug in known value, and when I say known value, this is what I mean. We get x equals a number, not in terms of like x equals 2y minus 2 or y equals -x minus 4, something like that. I mean x equals a number and y equals a number. So that's what I mean by known value. A variable back into any equation. It doesn't matter at this point. Once you have this, it doesn't matter. It can be any equation, and solve for the remaining variable. So in this case, we have x equals 3. So now we need to solve for y. It doesn't matter which equation we plug it into. We could even plug it into this one right here. Okay, it doesn't matter, but usually what you do is you plug it into one of the originals, so either this one or this one. I like the bottom one because the y is already by itself. That's some strategy you can use. Okay, the more times you do this, you can realize that the strategies that you employ make it easier and quicker as you go along. So what we're going to do is we're going to write 2 times our value of x, and that's 3. So I'm going to write 3 here. Okay, I don't know why I chose green. I should choose purple. So let me go back here, choose purple. So we have 2 times 3 plus y equals 8. Now I'm solving for y. That's my whole point. Okay, so that's the last variable. I need to get a number for y. So I get 6 plus y equals 8. Subtract 6, and I get my final answer, y equals 2. So now I have x equals 3 and y equals 2. So I can put it together as an ordered pair so that my answer is 3, 2. And that is my final answer. Okay, it's a location. It's where the two equations meet. So my x value is 3, my y value is 2, and that is the solution to both those equations. Okay, let's move on to example 1. What is, well, that was kind of our example. So example 1.1, what is the solution of y equals 2x minus 3 and then 2x plus 2y equals 12? This one's a lot more simple because we have this y already by itself. Step 1 is already done, and it gives us a hint. Very generous of this particular problem. So what we're going to do is we're just going to write 2x plus 2, and I kind of like this one because it breaks this down into kind of a real easy way to visualize it in case you struggled with the first one, equals 12. I'm just rewriting the second equation again, but this time all I'm doing is writing in the value of y in terms of x, because we're trying to get the x or the y by itself. In this case, it's easier to get the x all by itself because we were given the y. So we have 2x plus, we're going to distribute here, we get 4x minus 6 equals 12. Combine these, we get 6x, and we're going to add 6 to both sides, equals 18. We divide by 6, we get x equals 3. Once we have x equals a number, okay, we're almost there. We can plug it into either equation. I'm going to show you that, actually, how you can plug it into both, or either one, I should say. So we get y equals 2 times 3 minus 3. We get y equals, what's that? 6 minus 3, we get 3. Okay, so we get y equals 3, x equals 3. Now what happens if I plug it into this one? Let me show that here. So I'm going to change my color to, let's just go this blue color. So we have 2, and then I'm going to write 3, because I'm plugging in 3 for x. 2y equals 12. Now, we're already done. I'm just showing that you can plug 3 into either equation. So I'm plugging into the bottom one now, and I get 6 plus 2y equals 12. I subtract 6, I get 2y equals 6, divide by 2, I get y equals 3. It works in either one. Why does it work? Well, because we know there's an intersection. Okay, and we write it as an ordered pair with our x and y value. If there's an intersection, that means that if we plug in the value of x into either equation, we're going to get the same y because that is where they intersect. Our final example is a word problem here. We have guitar lessons. This is an advertisement for guitar lessons. There's 6 lessons for $300, or you could do 12 lessons for $480. The price includes a one-time fee. Okay, so x we're going to let equal lessons, and y we're going to let equal the one-time fee. Here's kind of like the formula for how we're going to set these up, each equation. The price is, the total cost is the price times the number of lessons plus the one-time fee equals the total cost. And that makes sense, right? If you have one-time fee plus the price, and if you go, depending on how many lessons you go to, that's going to determine how much your total package costs. We have a 6-lesson package and we have a 12-lesson package. So I'm going to let purple equal the 6-lesson package, and I'm going to let green equal the 12-lesson package. So let's go ahead and start with the 6. So we have the price, which we don't know. Okay, we don't know the price. We're going to call that well, actually, we're going to let that equal the number of lessons. Okay, so the number of lessons equals X, we already said. But the price, we don't know. We know that the total cost is 300. So we're going to have some sort of price. I'm going to put A, because we don't know the price, plus the one-time fee, which we don't know. We're going to call that Y, equals 300. Okay, so that's the first step. Then what we're going to do is we're going to set up our green lessons. So our green lessons, we're going to say, okay, our price, which we don't know the price per lesson, we're going to say A, times the number of lessons, well, that's X, plus Y, our one-time fee, equals 480. Now, we do know something for both of these. I said we didn't know the number of lessons, but with the package, we do know that 6 equals X. So we know that this equals 6. Okay, so that equals 6. And then we know that the number of lessons for the green package is 12. So that equals 12. Now, I don't like how that looks, so we're going to change this up just slightly. We're going to say 6A plus Y equals 300. And then we're going to say over here, 12A plus Y equals 480. Okay, now here's the whole point. You're like, whoa, I don't know what's going on. Well, that's the thing. We're not told how much each lesson costs. We're just given a lesson package. And we're not told how much the one-time fee is. We're just told the total package. We have two equations, two variables. Okay, so we have a variable here, here. We have A's that we don't know, and we have Y's that we don't know. So what do we do from here? We do a system of equations. Okay, we treat it as a system of equations and solve. So if we're trying to solve using substitution, what I recommend is solving for one of the y's. So here, I'm going to solve for the y here. This is my step one. I chose the y and not the a because I just chose the letter A. Okay, I can put that over here. Let me write that down real quick. A equals cost per lesson. Okay, sounds good. Or the price. I should write price so it matches up the chart. The price per lesson. Okay. I chose y because it has a coefficient of 1. So that makes it a little bit easier to solve. So I have 6a plus y equals 300. The first thing I'm going to do is I'm going to subtract 6a from both sides. Okay, so we get y equals 300 minus 6a. Now, what do I do with this? Well, I'm going to box this, and I'm going to move it with an arrow over here for the other y. So now I'm going to rewrite this, and the whole point was that as I write this, I get 12a plus, and I'm just going to put it in parentheses just to show you that I substituted. But the whole reason why I did this is so that I have only one variable, and that's a. And actually, I'm looking at this, and I should have done y because that's what it's asking. It's asking for the one-time fee. But I might as well go about finding the price per lesson also. So I'm going to try to find the price per lesson first, and then I'll go back and find the one-time fee. Okay, so then I have 12a plus 300 minus 6a. So I have 12 minus, we can get rid of the parentheses because there's no multiplication outside. So I'm going to do 12a minus 6a. I get 6a plus 300 equals 480. I'm going to minus 300 to both sides. And I get 6a equals 80. Going to have to do some division here. So I'm not 100% sure that's an even number, which is not great. So we get 80 divided by 6. No, it's not. Ugh. So we divide by 6, and I'm just going to simplify it here in fraction form. I divide both by 2. I get 40 over 3. Okay, that's around $13.3 in case you're wondering. Okay, so I'm just going to leave it as 40 over 3, and now I'm going to substitute it back into either one, and I'm going to choose just this one right there. That's fine by me. So I'm going to bring this guy down. Okay, for my solution, I'm going to use this color. Oops. I'm going to use this color. So I have 6a plus, oops, I forgot to substitute. 6 times my value of a plus y equals 300. I'm trying to solve for my one-time cost, which is y. And I put in 40 over 3 in orange. 40 over 3. Okay. When I multiply 6 times 40 over 3, essentially what's going to happen is this 3 cancels with the 6, leaving you 2. 6 divided by 3 is 2. So now I have 80 plus y equals 300. I subtract 80 from both sides, and I get y equals $220. So what is my upfront cost? My one-time fee is $220. And that's how you do a word problem with substitution. Stay tuned for next time when we talk about the elimination method. See you soon.